Hi guys, let's look at the next exercise. The next exercise is exercise 20D. Before we start the new exercise, let me just remind you that this year in your syllabus, which is we are talking about academic year 2020-21, exercise 20B, which involves area and perimeter of all types of quadrilaterals, is not in your syllabus, which means question number 2, question number 3, question number 4, question number 5, question number 6 of exercise 20D are not in your syllabus because they involve area and perimeter of quadrilaterals. So we are starting directly with question number 7. Good, let's look at the question. A very smart, interesting question. The perimeter of a semicircular plate is 108 centimeter. So let me just draw for our understanding a semicircular plate, which means if this is my diameter, then this part we are not bothered about. Perfect. So this is the semicircular plate that we are talking about, and this is the center and this is the diameter AB. So the perimeter, which means what will be the perimeter of semicircle? Well, so perimeter would be in this case be equal to 2 pi r upon 2. 2 pi r is the perimeter of the full circle, and 2 pi r upon 2 would be the perimeter of a semicircle. But in this we have an extended perimeter, which is the length of the diameter here, because 2 pi r is only the length of this part. So 2 pi r upon 2 is the length of this part, and to add this part we will have to add the diameter, which is 2 times radius. So this is perimeter of semicircle, and this is the perimeter of the diameter. Perfect. So this is pi r plus 2r, which means r times pi plus 2. Let's just solve this, and what we get, which means what we have is perimeter is 108, so 108 is equal to r times 22 upon 7 plus 2. 108 is equal to r times 22 plus 7 into 2, that's 14 upon 7. I've taken the LCM and I've added, which means 36 upon 7 r is equal to 108 centimeter. R would be equal to 108 into 7 upon 36. 36 1, 36 3. Therefore, the radius is equal to 21 centimeter. Perfect. So this is 21 centimeter. This is also 21 centimeter. Let's see what's the question. We need to calculate the area. So area of a semicircle is equal to half the area of the circle, which means pi r square upon 2. So in this case 22 upon 7 into r square, which is 21, into 21 divided by 2, which is into 1 upon 2 square centimeter. 7 1, 7 3, 2 1, 2 11. So this is 33 into 21. This is 3 3 6 6 3 9 6. So this is 693 square centimeter. Therefore, area of given semicircular plate is 693 square centimeter. Perfect. So interesting question to the extent that they wanted us to realize that the perimeter will not just be the pi r, but it will be pi r plus 2r. Perfect. Let's look at the next question. The next question that we do is question number 8. So question number 8 is two circles touch each other externally. We've done a question like this before in the previous exercise. I think it was question number 22. Perfect. Two circles touch each other externally. Sum of the area was 58 pi and distance between center was 10. This is question number 10 that I'm talking about. Now we have a exactly similar question, but this time this is exercise 5D, and let's see what we have. So let the radius of one circle be small r, radius of the other circle be capital R. Perfect. Sum of this area is 130 pi and the distance is 14. So let radius of circle 1 be r centimeter and radius of circle 2 be capital R centimeter. What is given is r plus capital R is equal to 14 centimeter, which means r is equal to 14 minus r. I had used one method for solving the previous question, which is the question I referred to, question 22, which we did in the previous video of exercise 20C. Let's try a different method of solving the same question. The second thing given is pi small r square plus pi capital R square is equal to 130 pi, which means pi times small r square plus capital R square is equal to 130 pi. Pi and pi gets cancelled, which means r square plus r square is equal to 130. That's equation number 2. So let's replace r small r in equation 2. So put r is equal to 14 minus r in equation 2. So when I put r square, which becomes 14 minus r whole square plus r square is equal to 130. Let's see what this gives us. So this gives me 14 square, which is 14 square would be 256. 4 4 is 16, 56, 4 1. No, not 256. That's 16. This is 196. My mistake. Getting confused. So this is 196. 196 plus r square minus 28r plus r square is equal to 130, which means 2r square minus 28r plus 196 minus 130 is equal to 0. 2r square minus 28r plus 96 minus 33 minus 30 is 66 plus 66 is equal to 0. Divide everything by 2 because all terms have 2 in common, or 2 as a common variable, which means r square minus 14r plus 33 is equal to 0. This time I need to find factors of 33, the sum of which should be negative 14. So that's simple, 3 and 11. So r square minus 3r minus 11r plus 33 is equal to 0. Grouping it like this gives me r times r minus 3 minus 11 times r minus 3 is equal to 0. R minus 3 times r minus 11 is equal to 0, which means r is equal to 3 centimeter or capital R is equal to 11 centimeter. Since small r plus capital R is 14, which means this capital R is 3, then small r is 11, and if capital R is 11, small r is 3. So which means the radius is 3 or 11. Perfect. Now let's read the question, figure out what they want. Find the radii of the circle. Therefore, radii of circle is 3 centimeter and 11 centimeter. Perfect. Let's look at the last question that we do from this exercise. The last question that we do is question number 9. Let's read the question. It says diameter of the front and rear wheel are 63 centimeter and 1.54 meter. So the rear wheel obviously in a tractor is much bigger. So these are the two circles that the two wheels that we're talking about. This is the front and this is the rear. The radius, the diameter is given. So diameter of front is equal to 63 centimeter. Therefore, radius would be equal to 31.5 centimeter. Perfect. So that's about it. Therefore, radius of the front wheel is equal to 63 upon 2 centimeter. Perfect. So this is 63 upon 2 centimeter In this case, let's call this r. Small r will make our life simpler for calculation. In this case, capital R is given as 1.54. So diameter of the rear wheel is given as 1.54 meter. Converting this into centimeter would mean multiplying with 100, which is 154 centimeter. Therefore, radius would be 154 divided by 2, which is 77 centimeter. 77 centimeter. Perfect. So this is 77 centimeter. Perfect. So we've just understood this part of the question. Let's see what do they want us to find. The rear wheel rotates at 24 6 by 11 revolutions per minute, which means this wheel is moving 24 6 by 11 times per minute. Find revolutions per minute of the front wheel. How many times would this revolve? And the distance traveled by the tractor in 40 minutes. Perfect. So let's just figure out the circumference of this, which will help us figure out the distance traveled by the rear wheel. Perfect. So therefore, circumference of a rear wheel, which is equal to distance traveled by the rear wheel, is equal to 2 into pi, which is 22 upon 7 into r. Into r in this case is 77. Good. We don't need to calculate the radius. Perfect. So this is distance traveled by the rear wheel in one revolution, which is one circumference. Therefore, distance traveled in the number of revolutions that we're talking about would be the same. Right? Distance traveled by rear wheel in 24 6 by 11 revolutions will be equal to distance traveled by one revolution multiplied by this, which is 7 1 7 11, which is 22 into 22. I could have done this calculation. This is 22 into 22 centimeter multiplied with 24 6 by 11, which is 24 into 11, that's 240, 264, 270. So this is 270 by 11 centimeter. 11 1, 11 2. So this is 44 into 270 centimeter. Yes, 44 into 270 centimeter. This is the distance traveled by the rear wheel in 1 minute, because these many revolutions happen in 1 minute. Now I have a simple question. Are these two tires of the tractor connected? Yes, they are. They form tires of the same tractor. So would the distance traveled by the rear wheel be equal to the distance traveled by the front wheel? Yes, it will be, because they are moving as a part of the same tractor. So it's not that the rear wheel is going somewhere else and the front wheel is going somewhere else. So the distance traveled by the front wheel in 1 minute would be equal to distance traveled by the rear wheel in 1 minute. Yes, so let's just write that down. Distance traveled by rear wheel in 1 minute would be equal to distance traveled by front wheel in 1 minute. Perfect. And let front wheel make x revolutions per minute. So it is making x revolutions. This rear wheel is making 24 6 by 11 revolutions, which is 270 upon 11 revolutions. Perfect. So distance traveled by the front wheel would be 2 pi r multiplied with number of revolutions, which in this case would be 2 into 22 upon 7 into r, which is 63 upon 2 multiplied with x. Yes, would be equal to 44 into 270. This is the distance traveled by the rear wheel in 1 minute. We just calculated 22 into 244 and 270. Perfect. So let's see if we can simplify something. 2 and 2 gets cancelled. 7179, which means x would be equal to 44 into 270 upon 22 into 9. 22 1, 22 2, 9 1, 930. Therefore, x is equal to 60 revolutions. Therefore, front wheel makes 60 revolutions per minute. So this is the important part of this question, of understanding that these two wheels of the tractor are interconnected, which means distance traveled by the front wheel will be equal to the distance traveled by the rear wheel if the amount of time is the same, which means 1 minute both of them travel the same distance. Perfect. That still leaves one part of the question. Let me erase this part here so I have space to solve the last part. This is distance traveled by the tractor in 40 minutes. So we know that this rear wheel makes these many revolutions, this much distance in 1 minute. So let's calculate how much distance will it travel in 10 minutes or in 40 minutes. So this is distance traveled in 1 minute. So distance covered in 1 minute we calculated as 44 into 270 centimeter. Therefore, distance covered in 40 minutes would be equal to 40 multiplied with 44. Yes, 40 multiplied with 44 multiplied with 270 centimeter. 1 minute, this much centimeter, 40 minutes, just multiply. So we will have to do this calculation. 44 into 4, that's 160 and 60, 176. So I have to multiply 176 with 27. And there will be 2 zeros at the end. Yes, 7 into 6, 42. 7 sevens are 49 plus 4, 53. 7 ones are 7 plus 5, 12. 700, yes, that's fine. 2 into 6, 12. 2 into 7, 14 plus 1, 15. 2 into 1, 2 plus 1, 3. So this is 2574. 4.74752 with 00 centimeter. Oh, that's a lot of distance to be written in centimeter. We can convert it into meter or convert it into kilometer. So if I divide this by 2 by 100, this will give me meter, and if I divide this by 1000, it will give me convert it into kilometer. So 00 and 00 goes, which means 4.752 kilometer. So distance traveled by the tractor in 40 minutes would be 4.752 kilometer. That brings me to an end of this chapter. Let's look at the homework questions. Question number 1 and question number 10 is the homework. Let's take 1 minute to revise what we did in this chapter. We talked about a circle, which was circumference was equal to 2 pi r, and the area, which was equal to pi r square. This was the last exercise, in fact exercise C and D. And in question exercise 1, we talked about Heron's formula, where area of a triangle was S times S minus A, S minus B, S minus C, the square root of this. This is what we did. We also did the regular area of triangle as half into base into height. Perfect. Thank you so much. Take care. Be safe. I'll see you with the next chapter. The next chapter that we do is solids. Bye bye.